Welcome to Zimcan IT. In today's video, we're going to demonstrate how you can upload a blob to your Azure storage account using Terraform. Okay, so for those of you that don't know, Terraform is an infrastructure as code tooling that enables you to deploy idempotent, version controlled infrastructure. Okay, so it has a plethora of benefits. As I previously mentioned, is idempotent, so what you deploy is representative of the code that you push, and in doing so you can sort of avoid configuration drift, technical debts, and many other things as well. You can collaborate with other individuals on the same infrastructure. You can store the history of your deployments via state files and so much more. And on top of what I just previously mentioned, we'll be uploading a blob. And so when we talk about a blob within the context of Azure, a blob is essentially Azure's object storage solution, we could say, which is a means of enabling you to upload a large amount of data that is unstructured and doesn't necessarily follow any sort of schema or model or definition. Okay, so you can upload your blobs in the form of text files, images, binary data, and the term blob itself stands for binary large object. And so when I say upload a blob, okay, the term itself, as I mentioned, means binary large object. But when you're uploading a blob to Azure, you're not necessarily just uploading a blob and that's it. What you're doing typically is uploading that blob within a storage container. And if we're going to look at it holistically, what happens is that you have a storage account which enables you to deploy various types of storage within Azure. So it could be a file share that you synchronize with your on-premises resources to the cloud. It could be a table that you add your log data for boot diagnostics of your sort of operating systems, or I should say your virtual machines, things of that nature. So you can upload queues, all sorts of storage solutions. But within the context of our storage account, we will have a container. And a container is essentially a means of logically separating or organizing your blob storage. Okay, so within your container, you'll then have your blobs. So in this instance, we're uploading files that are on our local PC, okay, to Azure within a storage account as blob data. Now, as you can see in front of us, we already have some Terraform configuration. So don't worry if you've not come across Terraform before. It's relatively simple once you get your sort of head around the syntax and how it works with different resource providers, modules, and the like. If you want to work alongside me through this sort of demonstration here, I have created a public repository containing the code that you see in front of you. So all you want to do is just make sure you've got Git enabled or installed on your PC, the Azure CLI, and Terraform as well. So you'll want to just hit the code option on this here public repository, copy the link, and then within your command prompt, you just want to hit the command git clone and then enter the link there that you see, which will then download or pull the files that you see within this public repository, and we'll be working within the infra subfolder. Okay, so let's just look at it from within Visual Studio Code. Okay, so you'll want to obviously clone this here repository I previously mentioned, navigate to the infra subfolder and take a look at the main.tf file. That's the only Terraform configuration file we'll be looking at today or reviewing today. So from a top-down perspective, what do we have? We have our Azure Resource Manager provider. Okay, so the Azure RM is the Azure Resource Manager provider offered by HashiCorp, enabling us to make remote procedural calls to the API endpoints for different services that Microsoft offer. So the public endpoints for your storage account, your virtual machines, they're all exposed via this Azure RM provider, enabling Terraform to then make those deployment calls, API calls to the given API endpoint, so long as you're authenticated to Azure by an acceptable method. Okay, so that might have been a lot to sort of digest, but there will be additional documentation pointing you to the means of authenticating to Azure using Terraform. This particular workflow is using a CLI. A CLI means of authenticating to Terraform. So all you'll really need to do, as I mentioned, is download the Azure CLI, then authenticate to Azure via the CLI, by entering the command az login. Okay, so once you've done so, you'll authenticate to Azure. Now you want to change into the infra subfolders I previously mentioned. So we're actually going to do that now. Okay, so we're within the infra subfolder. Good news. And if we review the code again, we've got the Azure Resource Manager provider. We have a random provider as well, which we'll see in use later on. There is a mandatory need to put a features block within your provider here for the Azure Resource Manager provider, even if you don't have any features that you want to have enforced with your Terraform deployments. We create a resource group, which is essentially a means of managing your deployments to Azure Cloud in a means that associates resources to a common workflow. So let's say, for example, you are deploying a new application or a web app to Azure within the West Europe region. Essentially, you would have a resource group that would contain the web app plan, the web app service, any sort of auto-scaling policies, any sort of metrics and things of that nature that you want to monitor within that given resource group, so that you can have all your resources within one sort of logical container for ease of management. You can assign policies that are inherited from the resource group, things of that nature. You can do quite a lot. So our resource group is deployed within the West Europe region. We then use this here previously mentioned random resource provider to generate a random integer, okay, between the values of number 10 to 500, and that is necessary for the creation of our storage account. So within Azure, okay, you need to have a globally unique name for your storage account. I believe the maximum character length or limits on the length of the maximum number of characters you can have within the storage account name is 24 characters. Obviously review the documentation just to verify that. But anyways, we create a storage account. It's a standard tier storage account. It's being deployed within the same location as our resource group, so it will be within West Europe. We're using LRS, so that's locally redundant storage, as a means of replicating our data only within a given data center. Okay, so we're not using GRS, which is geo-redundant storage, which would mean you have sort of your data replicated 3 times across your data center within a given region, and then have your data replicated to another region that makes up part of the regional pair that you have your data stored in. Okay, so how would I describe this a bit more succinctly? Essentially, Azure has regional pairs. So if you deploy your resources within East US, let's say it's paired to West US. If you deploy a storage account within East US and have geo-redundant storage enabled, essentially what's going to happen is you'll have 3 copies of your data scattered across your data center, okay, within East US, of which is also then asynchronously replicated over through to the West US region. And depending on what option you choose for your geo-redundant storage, you could also have read access to that storage, which is replicated over to your secondary region, which in this case would be West US. Now, again, we've got locally redundant storage. As for blob properties, we're enabling versioning, so we can track changes to our blobs. We are also enabling last access time, so we can view the last. It's kind of like a date modified feature, so you can view the last time that file was essentially accessed. Okay, in this instance, it's our files which we're uploading as blobs to our storage container, which leads us onto our storage container. I'm just going to ignore that. Leads us to our storage container. So we call our container blob container. There we go. We associate the container to a storage account. It's a private sort of access level which is assigned to this container, so you cannot have random anonymous reads on your blobs. There's no public access to the blobs themselves. And then we proceed to upload our blobs in different ways. Okay, so looking at the left hand side of the screen, we can see the hierarchy of our files here. Okay, so we have 4 subdirectories, 1, 2, 3, 4. Within each there is a file, so it could be t6.sh. They all contain the same message, we could say, just echoing out hello world. But needless to say, we'll be seeing how we can upload blobs or load files on our local system in different ways through to our Azure account. So the first way within which we're going to upload a blob, which is referenced as blob1 over here, is by simply uploading a file, okay, that is within the same directory as our Terraform configuration files, okay? So within the infra folder, you'll have your main.tf Terraform configuration file and then t1.sh. So if you want to upload just the t1.sh file, which is within the same directory as your Terraform configuration, you just reference the source by stating the file name here by source. Obviously, we've specified the type of blob we're uploading, so it's a blob. We associate our blob to the container within which it will be deployed in, as well as the storage account that the container resides in, and that's that. So it's pretty simple. The blob will also be named t1.sh. Now, if you want to upload a blob as a single file, which is within a subdirectory, in this instance, we're uploading a file within subdir-upload directory here. So if we just open that up on the left-hand side, you'll see there's t2.sh. Again, you just explicitly state the relative path to your Terraform configuration to that given file, and job done. Then it gets interesting, because now what we're trying to do is upload an entire subdirectory, including all the nested folders or subdirectories within that given directory. Okay, so take a look at what we're using here. It's the file set function. Now, file set will essentially allow you to upload files and their given subdirectories and the nested subdirectories within those subdirectories based on a given path and pattern. So if you wanted to upload just, text files within a given subdirectory, then you could do so by just explicitly stating the path within the first sort of input parameter option that you have there, and then stating the pattern. Okay, so in this instance, path.module simply points your Terraform configuration file, points Terraform, I should say, to the relative directory within which your Terraform configuration file sits in. And then the pattern we're using on the right hand side is the name of the directory we want to upload. And by stating 2 asterisks instead of the 1 here, we're stating we want to upload the subdirectories within this here directory, many-subdirs, and their associated files. Okay. Now, this will retain the same naming convention that's used on your local file system. So note that we are using a for each method of iteration here, and then just referencing the value of each given sort of subdirectory and its items by using each.key as the name and source. Okay, so the last means within which we're going to review here of uploading a blob is to actually change the, we could say the naming convention of the directories that you upload within your container. So we're going to create some directories here, dir1, dir2, and then within dir2, which is our second level down, we're going to upload a subdirectory and all its files. Okay, so many subdirs again. To the left hand side, let's just take a look at it once more. We have all these subdirectories and files. Okay, and so with that being said, let's do some Terraform. Okay, so you'll essentially want to start out by initializing your Terraform configuration. So just run the command terraform init. Okay, so it's successfully initialized. We run the command terraform validate, which just ensures that our configuration is syntactically correct. Well, that's a success. If you want to ensure that your code is properly formatted, then just run terraform fmt for terraform format. And lastly, this or penultimate step is going to be actually to deploy a plan document. So if we run terraform plan, you can then produce a plan document that is stored on your local system. So we'll just call this upload.tfplan, and then we'll let Terraform run. So it's doing its work in the back end, generating a plan document that will show us what Terraform is going to deploy prior to approving that actual plan that it generates. So we'll just let it run, and as we can see, if we scroll up, so we start out by saying that the following resources will be created: a resource group, storage account. Things such as the access tier aren't known until post deployment. So again, known after apply. Some values are, set as default, so as the TLS version. Again, it's 1.2 in this instance. Sensitive values are not outputted to the terminal, so again, you don't necessarily want to see your access keys within your plan documents, do you? So if we scroll down, this is still again sort of values that are associated with our storage account, so network rules. You would essentially set your network rules on a storage account if you wanted access to your storage account to be permitted only from a given IP range. So perhaps you would put your put the subnet for your on-premises data center as a network rule there, an inbound network rule. Then we start out with our blob. So blob 1, it's essentially one file, t1.sh. We have our blob 2, again one file, but it's within a subdirectory. Blob 3, again we're essentially enumerating all the subdirectories and files within the given many-subdirs directory we're uploading. And lastly, again blob 4, it just points to the fact that we're uploading again our subdirectories and their given files, in addition to creating a new file path within our container. Okay, so I do approve this plan. Okay, I'm pretty satisfied with the sort of schema that I've been presented. When we're told we're going to be adding 14 resources altogether. No changes are to be made as we've not uploaded anything just yet. And so if you just hit Terraform, apply, and then the name of our plan, I believe it was called blob. Actually, I'm going to auto approve, so auto approve, and then I think it was blob. What was our plan called? Upload. There we go. Yeah. So auto approve essentially is a way of enabling you to just apply a given plan without needing to approve that plan midway. Essentially, Terraform asks you a second time if you want to proceed with your apply. Okay. So we can see already that Terraform has begun creating our storage accounts random integer value in addition to our storage accounts resource group. So the resource group, which will then have a storage account within it. So that only took 1 second. It's quite quick, but I will skip through this step just so that we can get to the Azure portal and see what has been configured. So let's head over to Azure now. Within Azure, just within the search function, you can type in resource group, or if you're on the home page, just click on resource group. And if you don't see your resource group, just hit the refresh button. And again, storage account demo resource group, that is indeed what we deployed. And you can just validate that by going to Visual Studio Code and taking a look at the name of the storage account, of the resource group that you've deployed. Again, so it's right there. And that looks good to me. So if we then just minimize that, refresh, we'll then see our storage account has been made. Notice the random integer that's been appended to the storage account's name. So that's on the left hand side of the screen. You'll see that random.int resource. Okay. So let's just maximize this and take a larger look. Okay. So we're within our storage account. On the left hand panel, you'll see the option under data storage, containers. So click on containers, click on the blob container that we created, and you'll then see the files we've uploaded. Okay, so let's compare it to the file structure that we have on our local system. So the initial push or the initial upload of a blob was just the t1.sh file, which we see here. You'll see your other file there, which you uploaded within a nested subdirectory. So that was subdir upload t2.sh on the left hand side of your screen. And then we uploaded an entire subdirectory and its contents. Okay, subdir 1, subdir 2, subdir 3. And lastly, if we go back to the container, we made a new hierarchy of files. Okay, so looking at the Terraform configuration on the left hand side, dir 1, dir 2. So we go into dir 1 and then to the dir 2 subfolder, and then we have our uploaded folder many subdirs, okay, including its nested files and subdirectories. So there you go, subdir 2, 3, and 4. So job done. That was very simple with a bit of background explanation on what we did. So once you're done with your deployment, obviously you don't want to keep random files within your Azure subscription. You don't want to incur a cost for nothing. So just run the command again within the CLI. Ensure you're within the infra subfolder from the repository that you cloned, and then just run the command terraform destroy, okay, and then auto approve. Again, what's happening with the auto approve option or flag is that you're preventing Terraform from asking you again if you want to validate your destroy command there, if you actually want to run that destroy command. So Terraform then starts out by enumerating the state file. So you see here what says refreshing state. It's essentially just reading the state file and comparing it to the resources that are currently deployed to Azure. And if they are still present, it will then proceed to purge your given infrastructure after producing a plan. So it will say what has been destroyed, what is to be destroyed. So we've destroyed all these subdirectories and given files. If we then scroll down, it then proceeds to do the destruction or removal of those given files and subdirectories. It's really quick, and as you can see, it didn't take longer than 2 seconds to delete this here given file path. Okay, so just give it a minute or two and then you'll be done. And that is essentially the end of this tutorial. So if you want more information on the file set command that we used to upload subdirectories and their given nested directories and files, or if you want to understand what exactly, what a blob is exactly, why we use storage accounts, then I will link, some additional resources within the comments field, or I should say the description box of this video. So feel free to smash that like button, leave a comment, and peace.